Welcome to qnawire.
We want to find the initial speed of the grasshopper, and we can see here for part A, the final y velocity is going to be 0 because it hits the ground, and so we can say that here vy final squared equals vy initial squared. This is going to be plus 2 times the acceleration in the y direction times delta y. And so we can say that here vy final is going to be 0, and we can say that the velocity initial in the y direction would be equal to the square root of -2 times a sub y times delta y. This is going to be equal to the square root of -2 multiplied by -9.80 meters per second squared multiplied by 0.0674 meters. Extend the square root, and we find that the initial velocity in the y direction is equaling 1.15 meters per second. We know that here the initial velocity in the y direction is equaling the initial velocity times sine of the initial angle. So essentially, the initial velocity of the grasshopper is going to be equal to 1.15 meters per second divided by sine of 50 degrees. And this is equaling 1.50 meters per second. This would be the initial velocity of the grasshopper for part A. For part B, we find the height of the cliff, and so we can say that we're going to use the horizontal motion to find the time in the air. And so we can say that there isn't any acceleration in the x direction, so we don't have to account for that term. And we can say that here delta x is simply equal to vx initial t. And so t is going to be equal to 1.06 meters, and then this would be divided by the initial velocity 1.50 meters per second times cosine of 50 degrees. And so t is equaling 1.10 seconds. And now we can find the vertical displacement of the grasshopper at 1.10 seconds. We can simply say delta y equals the initial y times t plus 1/2 a sub y t squared. This is equaling 1.15 meters per second multiplied by 1.10 seconds plus 1/2 times -9.80 meters per second squared multiplied by 1.10 seconds quantity squared. This is equaling -4.66 meters. So we can say the height of the cliff is going to be equal to 4.66 meters. This would be our answer for part B. That is the end of the solution. Thank you for watching.